What's going on, guys? It's Brandon, and we're going to make a little video here on the stairs. And so for those of you new to the channel, I don't just talk about fast cars. I talk about some really deep shit. So let's talk again about cancer, and let's see if anybody can properly define cancer. And the answer is no, people can't properly define cancer. And why is that? It's because people have not yet even properly defined a healthy cell. And for those of you who are like, okay, who taught you this one? This is one of those things I figured out on my own. So follow me here. In simple terms, if you ask any top biologist, any top physicist, any top doctor, anybody who thinks that they know, my molecular biologist, anybody, if you ask them what's a cancer cell versus what's a healthy cell, they'll say a cancer cell is a cell that doesn't know when to stop replicating, and it just keeps replicating over and over and over. And you say, okay, so then a healthy cell is a cell that knows when to stop. It knows when the job is finished, and it doesn't need to do anything for a little bit. And so it doesn't just keep replicating over and over endlessly. And they say, right. And that's their definition of a healthy cell. Okay? Does anybody see the problem? We're not going to dwell on this too long. I'm going to jump into it. I'm going to explain to you what the problem is. And I've explained this in the past on the previous channel. I think I've explained it once or twice on this channel, but I'm going to keep reiterating this because this is a really big one. And illogical people don't care. It's like talking to a dog or a cow. You tell them something, they're like, oh, I don't care if it's illogical. I don't care if it's illogical. Okay, so let's talk about a healthy cell. So before we do that, let's talk about the Ohio State Marching Band. Okay, the Ohio State Marching Band, they go out there and they make shapes. Like you've probably seen it where they do like Michael Jackson moonwalking across the field, and they do like the script Ohio. They do these things. So from a bird's eye view, they're in the right spot, right? But how did they get to the point where they could be in the right spot? You say, well, they haven't memorized what to do. Okay, they haven't memorized. That's intelligence. But still, before they memorized it, how did they get to know where the right spot was? And the answer that I'm digging for is, you say, well, they had practice. Okay, I'm going to dig a little harder now. At practice, what occurred to tell them whether or not they were in the right spot? There had to be a bird's eye viewer. There had to be a person up on a big step ladder from up above yelling with a fucking megaphone. You step a little bit this way. You step a little bit this way. Okay, now you are going to follow the guy in front of you, and you're all going to march to this beat with the drums. Right foot first, left foot second. Dot, 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 dot. Okay. And then you are going to stop on the 50-yard line. You're going to stop on the 30-yard line. You're going to stand next to him. You're going to stand next to her, but in front of him, behind her, blah, blah, blah. You're going to have this big of a gap between you. You're going to do this. You're going to do that. You're going to move. Okay. For there to be practice, there has to be what? Communication. There's the answer, right? If you don't believe in magic and you believe in logic, there has to be communication. Let's do this again. What's the difference between a cancer cell and a healthy cell? So now I'm going to ask another question that the scientific community doesn't have the answer to. And they don't like to admit that they don't have the answer to this. Here's my arm. Inside my arm, there's a couple bones in there, right? I want you to imagine for a second that you have X-ray vision and you can zoom in to one of the bone cells on one of the outer edges of my bone, okay? On one of my arm bones. So obviously there's millions and millions of cells on the exterior of my arm bone, and then there's a whole bunch of other bone cells inside the bone, like that are buried underneath other cells. But the ones that are on the very outside layer of the bone, that are rubbing up against the muscle and the cartilage and rubbing up against blood vessels and all these different things, the ones that are on the outside edge of the bone, if you were to go do surgery and scrape one of the bones away, chip it away, what's the bone do? Especially when you're younger, what's the bone do? It heals. How does the bone heal? What is the process of the bone healing? The process of the bone healing is the cells that are nearby the chip start to replicate over and over and over until they bond together. And then eventually, after they create a little bit thicker of a spot because they reinforce, it's like smart engineering. You break a control arm on a car, you say, okay, the control arms need to be thicker. This part of the bone got broken. Well, I guess we need to make that part of the bone thicker. The point is the body is intelligent, and not only does it repair itself, it reinforces itself. But now, again, I'm going to ask you this question. How do the cells know when to stop replicating? And in your feeble mind, in everyone's feeble minds, they answer, because they're done. They fixed the spot. Okay. I want you to imagine now that you are a bone cell. Okay? According to you guys, the bone cells have no eyes. They have no ears. They're not that smart. They're all hooked to each other like Legos. But then all of a sudden, let's say the guy next to you gets chipped away. And let's say you were on the outer edge. So let's say there were, in simple terms, let's just think of it like a Rubik's Cube in the sense that you've got 5 cells around you, and you're in the middle. Okay, you're like number, not 5, it's 9 on the face of a Rubik's Cube, 3, 3, and 3. Okay, so you're in the middle. There's 8 guys around you, and you're in the middle of the lattice. Okay, so there's 8 people around you. A couple of the guys over here are gone. They got chipped away. Now you say, well, it's easy. He knows he's supposed to replicate that way. Okay, but let me ask you a question. How? Remember, it's the face of the Rubik's Cube, and there's a bunch of other qubits, whatever they're called, underneath this face. There's a bunch all the way through your bone. There's all these different cells. How does it not know, or how does it know not to replicate upward? Well, it's in the genetic code. That's like saying it's in the rules for the Script Ohio, the marching band. You still have to have someone on a higher level telling you, are you in the right spot or not? Even if you've got the treasure map, even if you've got the blueprint in your DNA of where you're supposed to be, you still have to communicate with something that has a bird's eye view of, how's the bone look? Is the bone fixed? Because I can't see anything. And even if the bone cells could see, let's say they can see, let's say they have eyes of some sort and they can see, okay? Or they can sense each other's presence. Even if they could see and all these different things, now the next question is, how do they know when the bone is done? For instance, when you're 4 years old, your arm bones are the same length. When you're 8 years old, your arm bones are the same length. When you're 20 years old, your arm bones are the same length and the same thickness roughly. How is it that they both on 2 different parts of your body grow uniformly? And how is it that if you break one and it gets fixed, and it fixes itself, how do those cells know when to stop replicating? How does this cell right now on my arm bone, on the surface of my arm bone, that's right next to the muscle tissue, how does it know that it's not supposed to replicate again to make the arm bone the right shape? How does it know? You say communication. With what? The other bone cells. No. That would be like a bunch of people on the marching band field. They can all talk to each other. They're not going to create the perfect Script Ohio unless you have someone from a bird's eye view. Now, I know a lot of you are thinking, oh, that's God in the cloud. That's the metaphor, at least, okay? See, scientists hate when we go here because now scientists are in trouble. Because scientists don't like to believe in God or they don't like to believe in ether. And ironically, ether is more than likely the way that if there is a God, it communicates with our cells. Okay? Now, even if there's not a God, I still believe there's ether. If you said there's no ether, then I would say there has to be a God. How about that for some profound shit? I know most of you don't even know what ether is, and I'm not going to get into all that right now. But the point is, not only does there have to be someone with a bird's eye view, something with the bird's eye view to tell these cells, yeah, looking good. But here's the paradox. The cells are the ones who ultimately decide what they're going to do based on their DNA and their mitochondria. So the DNA in the mitochondria gets messed up. When they get messed up, the code gets messed up. They start producing a whole bunch of lactic acid. When there's a buildup of this lactic acid is when your cells mysteriously, I'm just being very scientific with you guys here for a second, that is when your cells mysteriously lose communication with whatever it is that they're communicating with to tell them when to stop replicating. Or they still have communication with the thing that tells them to stop replicating. And due to their code that they have inside them, they say, here's what I believe the arm bone should look like. How are we doing? You got guys here and there, and it's a little bit great. That's fine. We're gonna keep going. How's the script Ohio looking? You're not spelling Ohio right. You have an S on the end and a P on the front and an M underneath, and those guys over there started spelling Michigan too, and it's just supposed to only say Ohio. Great, that's what the plan was. We're supposed to have a P and an S and a Michigan underneath. That's what we were doing. Oh, I'm not sure about that, but okay. So what you have to realize is when a cell has corrupted code, not only does it have corrupted code, but it's either the communication device that it's communicating with to get the bird's eye view of how far it's gone. Either it can't hear it anymore and it just ignores it and it just starts replicating blindly, which is very plausible, or its screw up in the code makes it think it needs to add the P and the S and the Michigan underneath the script Ohio. And so it's very well aware that it's gone further than the other bone cells wanted to go, but it says, I don't care. This is what I want to do. This is what my code says to do. What's the difference between a healthy cell and a cancer cell? You can't answer that question until you first describe everything that a healthy cell is capable of doing, capable of communication, capable of communicating with something that gives it a bird's eye view of where it's at. Because you got to understand, these cells, they're in the dark. They can't see anything. They're covered up by skin and muscle. They don't know if they've made the arm bone the proper shape. Something has to communicate with them that they have. Now, there's another option. Maybe the cells themselves don't communicate with each other. Maybe the cell is a city, like a village, like a skyscraper. It's this thing that's constructed by smart little creatures. So you say, what do you mean? Well, maybe not only are protein mechanisms alive, and maybe those protein mechanisms communicate. So it's not the cell, it's the littler things. But go a step further. Maybe there's something even smaller than the protein mechanisms. Maybe that's still the Corvette. Okay, that's the walking machine. Like on Star Wars is the protein mechanism. So you got the city, which is the cell. You got the protein mechanism, which is the walker on Star Wars. But then if you go smaller, you get down to atomic components, which make up molecules. Atomic components like electrons, neutrons, and protons. And if they're alive and they're able to talk to each other, that could be also how this all takes place. And you say, what if there's something bigger talking to the cells? Well, what's bigger than the cells? You got like the heart, you got the lungs, You got the liver. Do those talk? Do those have a bird's eye view of each other? No, they're all layered away between muscle and they're in the dark. So the only thing bigger than your cells that's conscious that you know of is you. Do you tell your cells when to stop? Hey, hold it right there. Hold it right there. Yep. A little more. Replicate. Oh, perfect. Good job. No, you don't even have x-ray vision. You can't even see. So it's not you doing the communication. And then if you go bigger again and you start asking, okay, is it God? What's between us and God? The earth and the sun? Is the earth or the sun making these decisions? Not necessarily, no. If they were, they'd have to be communicating through a very small substrate called ether, okay? But now we're going to go down another layer. Let's say that atoms are responsive because they're alive. Electrons and protons and neutrons are alive and they're all swimming around inside of the ether. And let's say that inside of the ether is the true intelligence. And what's interesting is science has taken everybody into left field with the God particle. We're looking for the Higgs boson. We're looking for the God particle. Everything is a deviation of truth. Everything is like, take everybody over here to left field. The double slit experiment is a magic trick. I'm telling you right now, it's a magic trick. They know what they're doing. They're distracting everybody. But the point is, I'm on a planet with 8 or 9 billion people who don't understand that longer life is easily accomplished as soon as you can figure out how to kill cancer, because then you can turn telomerase back on. And those people are, for whatever reason, not smart enough to even want to define properly what is the difference between cancer and a healthy cell, because the people aren't observant enough and don't have a high enough IQ to ask themselves, riddle me this, Batman, how does this cell on my arm bone know when it's done replicating? How does it know that it's fulfilled the shape of whatever blueprint that it has in its mind? How can it see itself? How does it know where it's at? I mean, you tell me how a little cell in the middle of your arm bone even knows whether it's in the last inch of your arm bone or the first front inch of your arm bone when your arm bone is, a foot long. How do these cells, or 18 inches, whatever, how do these cells even know where they're at in the bone and then know whether or not they need to replicate again? You don't have the answer, Brandon. Right, but at least I'm fucking exploring the possibilities. It's more than can be said for the rest of you. What do you guys think about in a day? It's like farm animals. Like, what the fuck do you guys actually think about in a day? And the thing is, you guys are like, oh, I'm sophisticated. I graduated from Harvard, blah, 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 and I know all there is to know. And, oh, blah, 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 blah. No, you don't. It really bothers me how just oblivious you guys are. I've never heard a cancer doctor explain this, by the way. I've never heard a molecular biologist, atomic physicist, chemist. Who taught you this, Brandon? Some of us are able to observe things and teach the rest of you, like Sir Isaac Newton, or Galileo, or Ben Franklin, or Nikola Tesla, or Steve Jobs. We just figure shit out. And the rest of you, I don't know what the fuck you guys are. Like, I don't know. That's all I got for that video. See ya.